tirarlo su.
Prova. Ah,
Okay, I think we can start. Welcome, everyone. Okay, today's first speaker for me is Federico Belotti, also known as Belo, who is a great ex-coworker of mine, ex-colleague. And he has a talk with a very short title, that is ChatGPT and Minecraft Diamonds Playing Agents, Reinforcement Learning in a Nutshell with ShipRL. So if you have questions, I remind you to ask on Slido. I will ask at the end of the talk. We will have 5 minutes Q&A. So welcome, Belotti, and the floor is yours.
thank you. Okay, so good morning, everyone. I'm Federico, and today I'm going to talk about reinforcement learning. So first we will ask, what is reinforcement learning, of course. Then we will move to asking why and who is using it. And then we will see how one can learn its own reinforcement learning agent, given it's outside in the open source community. So what is reinforcement learning? Basically, it can be depicted like in the following figure. So we have an agent that has to take action into an environment. And those actions are conditioned by what the agent sees from the environment, by what it perceives. And essentially, what it does, the goal of the agent is to maximize the rewards that the environment gives to it. And the reward is just a learning signal, so it's a number, and it's telling how good or bad the action that the agent has taken was. Okay, so that is the overall intro about reinforcement learning, and this continues endlessly. Hopefully not, because I mean, until the agent has converged to a known behavior, and it's like in a loop. So the agent keeps taking action into the environment gives a reward, and it's changing continuously its states. So given the new observation and the new state, the agent takes again another action, and it keeps going on like that. Okay, so it keeps gathering experiences and use those experiences to improve its own behavior, to solve the task at hand that it's represented by the reward. So if, for example, if we want to train an agent to play the Pong Atari video game, essentially what it does, it's at the beginning of the training, random action. So it doesn't know anything on what is going on, how the world is behaving, and some time passes, so the agent has gathered a lot of experiences, and it starts to understand movement. By the way, the trained agent is the green one in here. So he understands movements and almost understands the velocity, because he needs to know that if it hit the ball with the right angle, it can give it speed, and so it's more probable that it can beat the opponent, like in this case. But it's not quite well trained, this agent, right? By the end of the training, what we want to achieve is that we have like a perfect agent in which he understands perfectly movements and velocity. As we can see, like in here, he hits the ball and he gives it speed, so he can beat the opponent like that. So this is how the training works, and it keeps gathering on and on and on experiences until it becomes very good at what it has been trained. So why reinforcement learning? I mean, there's no, reinforcement learning is one of the three learning paradigms. So the other two are supervised learning and unsupervised learning, right? So why one wants to use reinforcement? And well, it's simple and it's general, because the only thing that the agent needs to do is to maximize a reward. So there's no labeling, there's anything. The only thing that you need is a mathematical function that is the reward, and that's the only learning signal that the agent needs. And if you want to change the task, it's super simple because you only have to change the reward, right? So you can train an agent to be perfect at beating an opponent, giving, I don't know, a +1 reward if it wins the game and a -1 if it loses. But you can have maybe, if we take the example of Pong before, you can give a reward if it hits the ball at a 45 degrees angle, which is crazy, but you can do it, right? And the only thing that you have to do is to change the reward. And so adding auxiliary task is straightforward because you keep adding those rewards, and as long as the agent is going to maximize those rewards, you can learn new tasks then, like that. So it goes, in its formulation, it has purpose and planning right off the shelf, because when an agent takes an action at a particular point in time, he needs to reason about the future outcomes, right? Because I'm an agent, I'm taking an action right here at this time, and I have to understand that in the future, my action will have some consequences, right? So it's the only training, like learning paradigm in which you can have purpose and planning, which you cannot have like when you have supervised learning and you're training, I don't know, a model to reason about images, for example, right? And then you can have also the ability to incorporate human-like traits like curiosity, which is something that we have since we are born, imitation, and that kind of field is called imitation learning. And then you can also have feedbacks from the human, so you can have your agent aligned to the human preferences. So who's using it? Well, the list is almost endless, and we have different fields from energy, video games, NLP, finance, robotics, healthcare. But there are some notable examples. So in the video game community, we had StarCraft 2, Dota 2, which the OpenAI researchers has beaten the team champion of Dota 2. We had also MotoGP 19, in which we had, as Aerobics, we have developed an intelligent agent to beat the lap time in a MotoGP track. And then last year we had Gran Turismo 7 with Sony researchers. In the NLP field, all of us know the ChatGPT, and it has been trained with reinforcement learning, human feedback, and without that, it wouldn't be able to give us those human-like responses that we know of. And then in the field of the machine learning community and deep learning, there was the Alpha Tensor, which is the first one that I will talk to you about. And do not be scared about it's essentially what they have done is matrix multiplication. It's like known from a lot of years, right? And there is one algorithm that it's dated 50 years ago, in which essentially you can multiply two by two matrices in 7 steps. So you have to do 7 multiplication, right? And if you're able to find a way to do those multiplications, those matrix multiplication with fewer steps, it means a lot, like, because deep learning is based on matrix multiplication, machine learning, I mean, everything. And so what they've done, the key insight here is that if you are able to view your problem as a game, you can use reinforcement learning, and this is what they have done. Essentially, they have taken the matrix multiplication problem and they have transformed it into a game, and they have used basically Alpha Tensor, which was an agent that has beaten the Go champion, which is a chessboard game. And once you can do something like that, I mean, the options are really endless because you can use whatever agent you want. And they, in fact, they have discovered a new way to multiply 4 by 4 matrices. So the known steps were 49, and Alpha Tensor has discovered a way to do it in 47, which, I mean, we can think, okay, it's just 2 steps fewer, but it means a lot in terms of computational saving, timing, costs, and whatever, right? So this is one of the first example. And the second one is an agent that has been developed by DeepMind researchers. It's called Dreamer because it can dream of future outcomes. And what they've done is that they have trained it to craft a diamond in Minecraft, which is crazy because, I mean, for the agent, it needs to know where to go grab the tools that it needs, how to find it, how to combine it, where they are stashed in the inventory, and something like that. So it has a lot of planning, as we have talked before. So you need to know what you are doing now, because the overall goal is, I want that diamond, right? So it's super crazy, and it's super cool, this one too. And the other one is the training procedure that has been used to train ChatGPT, which is reinforcement learning human feedback. And this is like divided into 3 stages. And the key insight here is that the agent can be anything. Like in this case, the agent is a language model, and a language model is just a model that is trained to generate sequences, right, in a natural language. And what I've done is that the needs was, okay, how can I have my language model to answer me or to summarize some text as a human? So from what we have said, we need a reward, right? How can you mathematically define be like a human? I mean, it's impossible, right? So what they've done is that they have asked some humans to rank the generated responses from the language model. And in that case, they have learned what they've called the reward model. So it's a model that it's able to mimic the ranking from the humans. And given that, you have a reward, and you can just use a single, like a standard PPO agent, which was developed like in 2017. It's super basic. And given that, the language model has been fine-tuned to follow the human preferences, right? Which is something that in other fields it cannot be done like that, right? So this is also a nice, cool thing to have. And then there was MotoGP 19, and in our company we have like developed the first deep reinforcement learning solution to like beat the lap time in like Mugello or Jerez or whatever track. And it was super cool and fun because, I mean, human player can have more fun, and it's more engaging, right, from the point of view of the player. So how one can create and train their own reinforcement learning agent? Well, ship your agent with shipRL, and the QR code is pointing to our GitHub repository. And I mean, it's super easy because essentially with almost like one line in the command line, you can have your PPO agent trained in the Pong environment, which was the one that I've showed you in the first slide. So it has been trained like this. And if you want to run it over multiple GPUs or multiple TPUs or whatever in your clusters of machines, and you can do it with Lightning Fabric, which is another open source project that gives you the possibility to accelerate your deep learning pipeline or whatever on multiple machine and accelerators. And so it's super easy. Also, the code that we have written, we have tried to take like everything regarding an agent in a single folder in the repository, and so you don't have to like jump around the repository and try to understand what it's doing. The interaction with the environment and the agent, it's super clear, so you can have a look. And what we have done is that we have like a couple of two kind of architectures. One is that we have called coupled, in which we have like a bunch of processes. Everyone has their own agent inside, and different copies of the environment, so that we can run multiple like experiments and gather a lot of experience in parallel. And they talk through the network, so they exchange their experiences through the network, and they are trained with standard the code is written in PyTorch, so we are using like distributed training from PyTorch. And so this one is the first architecture that we have, and we also have another one which resembles more the first slide in which you have the agent and the environment decoupled, right, separated. So in here you have like one process in which you have all of your environments, and all the other processes are just taking care of the training, so that you can have like your environment that it's running on one machine with, I don't know, a lot of CPUs, and then for the bulk of the training, you can have your own processing in another machine with multiple GPUs, so you can like separate your training, right? But this is all hidden, because it's just like, as I've showed you before, like Lightning run model, and then you can tell, okay, run these on CPU and the other one on GPU, so it's super simple. And as last example, we have like trained a Dreamer agent, the one that crafted the diamond in Minecraft, to play the famous Pac-Man. And also in here, I mean, it sees that it goes like, it's doing random action, right? It doesn't recognize anything, the monsters, and in fact, like it loses badly. Half of the training, you start to understand, okay, maybe if I take the pills, I get more points, but it doesn't understand that the pills give the possibility also to eat monster, right? Because in that case, he's hiding from the monster because he doesn't understand. Well, in the end, it's super cool because it goes straight to the pills, and then it goes chasing monster because he knows that he can like eat them if they are blue, and in fact in here it goes to like, yeah, chasing the monster. And the beautiful thing of Dreamers or Dreamer is that he can dream, right? So in here what we have done is that we have tried to understand what he's dreaming of. And from what we see, it's like the Pac-Man starts in the bottom right corner, and it dreams to go up over in the right in the top right corner and eat the blinking piece. So this is what the model is dreaming, and it's also super useful to understand like what is thinking. And that's it. Thank you for your attention. Yeah, go ship your agent, whatever you want. And also, I want to recommend another talk from our colleague, Rafik, calling like the controlling the chaos when you have like a lot of experiments in deep learning and you have to run those, how you can do it with Lightning and Hydra. That's it. Thank you.
Okay, thank you very much, Belo. Great talk. So we have some questions. The first one is, just one sec. Okay, so how difficult is to design a good reward function compared to labeling in supervised learning?
That's a great question because it's super difficult. I mean, the thing is that if you have something that can be like mathematically defined, it's super easy. So for example, when we have done the milestone experience, there were a lot of rewards that can be computed. Like if I go out of track, it's something that you can measure, right? But when you start to think about like the styling guide of the NPCs, that is difficult. It's like asking a language model to be a human. You cannot like quantify it. So there are some solutions to that. So you can use like imitation learning. So you can give the agent a bunch of demonstration, and the agent tries to mimic essentially your demonstration. Or you can have the human feedback. If you don't have something to quantifiable, you can have like, you can align to the human preferences, and you can have a designer saying, okay, look, I prefer this styling guide with respect to that one. And then you can like inject your own preferences, because otherwise there's no, I mean, it's super difficult to come up with a reward, yeah.
Okay, thank you. Second one. So in the example of MotoGP, the difficulties of the game, like beginner, normal, or expert, are based on how much time the agents have been trained?
No. So the agent has been trained to compete and to be like almost superhuman, and then I think that they have done something in like a post-processing on the agent behavior to uh, so that it doesn't beat like uh, the human every time. But this is can be another solution. So if you want to have like an agent that is quite well, maybe you can like stop the training, not at the end, but maybe tre quarti, non so come si dica.
Okay.
After the half training, maybe you can stop slightly before, so you can have a not full trained agent.
Okay. We have a lot of questions. Great. So aren't there inherent risks and pitfalls for reinforcement learning-based agents when modeling the reward is non-trivial, like reward hacking in Coast Runner from OpenAI?
No, sorry.
Okay, maybe if the one who asked questions
it's
want
here.
to elaborate.
Okay.
It was actually me. I don't know if you saw the simple like use case of not use case but showcase of reward hacking. So when like an agent tries to basically like we specify a reward like finish the GP like the MotoGP race
Sure.
imagine.
Okay.
But maybe the agent like you specify some form of reward and maybe the agent does that by I don't know like looping on the
Ah, yeah. It's really cool. In fact, that is one of the use case in video game is for like automatic testing. So when you know that your agent is hacking your word or whatever, it means that it's something going wrong, right? Because I mean, the only thing that it knows, the agent is I have to maximize the reward. And if I have, I mean, if I win the lab because I don't know, I go underground and then reappear somewhere else, it's a problem. And so you can use those reward hacking to understand what is happening both in your environment or in your agent. So
are there ways to detect it without like looking at what the model is doing?
I don't know. I mean, like here, I don't think so. You have to look, yes, at what it's doing, and maybe if you can track rewards, or if you have something that you can measure, like in the MotoGP track, you know that maybe a track is long 5 kilometers or something like that. If he completes a lap in 2 kilometers, there's something wrong, and you say, okay, wait, and then you can inspect or something like that.
Okay, then how long does it take to train an agent like Pac-Man to finish the game? And how far in the future is he dreaming?
Okay, so it takes a long time because, I mean, for Dreamer, it's a pretty huge model, so it has a lot of components because it has to understand word models. So we have like recurrent layers, like LSTM, so we have a lot of MLPs and stuff like that. So the training itself, it's fast because if you can run it on a modern GPU, just one single epoch, it takes seconds, right? But the huge time that we spend is the interaction with the environment, because in that we don't have any control, right? Because the environment is given and it runs on CPU, and so you just have to wait. And so for Dreamer, it takes like a long time. So like we have run experiments, and I think that Pac-Man is already like it's going on. But to reach that point, I think 2 days on 2 GPUs, something like that. And the next.
How far is he dreaming in the future?
How far is it dreaming? There is hyperparameters that you can control. So during the training, you can set the horizon, and we have set it to 15 steps, so it can dream 15 steps ahead. So, and that is what we have plotted there. So it was dreaming like 50 steps ahead, but I don't know. We can also try to let it dream for more and more, but we haven't seen. So it's something that you can control.
Okay, great. Then the next question is asking you if you know Voyager, that is an open-ended embodied agent with large language models showcase the possibility of gradient-less in-prompt RL in GPT-4. Have you seen it?
What is called?
Voyager.
Nope. No, is it here, the one?
No, it's
guy?
always me.
Okay. Okay. No.
It's a paper that has been released like a couple of days ago, but made like super splash in Twitter and reinforcement learning.
Wow. No, I haven't seen. Can you send me the paper?
Yeah.
Okay.
Yeah, the nice stuff is they basically do RL without ever training the GPT, for instance. They just like basically do RL on the prompt.
Wow.
And it can learn how to play Minecraft like really well. And I think it beats Soda. So.
Yeah?
Yeah, I think it beats really.
With just a language model?
Yeah, with just the prompt of language model, without ever updating the weights. They just train basically everything inside the prompt.
Okay.
Yeah.
Wow. Yeah. Give me the paper.
Yeah.
Okay, great. Last question is, can I use ShipRL, so your platform, to train the agent against itself? For instance, about the Pong game, can the opponent be a different instance of the same agent?
I don't know if in Pong you can do it, but yes, I mean, if you want to implement your, it's called multi-agent reinforcement learning, in which there are a bunch of agents, both cooperating or they are one against each other in the environment, so you can also have something like this, and they can like share a policy, so a behavior or not. So if you, I mean, I don't know if the guys is here. No, okay. Okay. So if you want, I mean, if you want to contribute with something like we can have it, but we haven't implemented it yet inside the ShipRL. But once you have it, I mean, as long as you have an environment and an agent implementation, you can do whatever you want, essentially. So it can be done.
Okay, great. I think there are no more questions, or if someone here wants to ask a question, we have a couple of minutes maybe. Okay, otherwise, thank you, Belo.
Yeah,
great talk.
Thank you too.
And thank you, everybody. Okay, welcome everyone. We are ready at last. So welcome to Sartik and Vikram, and they will talk to us about working with multiple hands, parallel and distributed programming. I remind you that if you have questions, there is Slido. Please write them in Slido, and I will ask them the questions at the end of this session. So the floor is yours. Welcome.
Hi all, I'm Vikram. I'm a graduate student at Columbia University. So first half of the talk will be given by Sarthika. I'll hand over the mic to her.
Hi everyone. So I'm Sarthika. I'm a software engineer at Microsoft, and today we are going to talk about parallel and distributed programming and using a standard known as message passing interface, or MPI. Yeah. So first, let's quickly go over the agenda. We will start with a quick discussion on the key differences between concurrent and parallel programming, followed by a detailed discussion on the crux of our presentation, that is MPI, and how to use it in Python. We will see how to use MPI for both parallel and distributed programming, along with some examples. Then we will have a quick glance on what are the things to consider while writing parallel code, and what mistakes to avoid, and this will give us an overview of what are the best practices to follow. In the end, we will have a fun trivia and a Q&A session, and we will conclude the presentation with that. Right. So let's first see how performance of programs can be improved. So there are two ways. One is concurrent programming and one is parallel programming. If you see the figures here, there are two tasks that need to be executed, T1 and T2, and they have both been divided into multiple pieces. In the left figure, you will see that T1 and T2 are interleaved, but at any given point of time, only one of them is getting executed. While in the second, in the right side figure, we will see that T1 and T2 are getting executed simultaneously, like they are getting executed at the same time also. So the left one is known as concurrent programming, while the right one is known as parallel programming. Concurrency is a broader term, but here we are using it to mean something specific, which is the left one. So this is the basic difference. We are using the words interruptibility and independentability here. These are not actual English words, but they do a good job in explaining the difference between concurrency and parallelism. Yeah, so as previously explained, concurrency is the execution of multiple instructions within the same time frame. So for example, we can consider if there is a queue at a bank and there is a separate queue for senior citizens, and there is only one teller. So the teller will alternatively switch between the two queues and making like both the queues progress together, but at a time only one queue will progress. So that can be taken as an analogy to understand concurrency. And it's a semantic property of the program, which means that we have to consider the design of the problem at hand. Like the task should be able to switch between themselves, and we have to design it in such a way. Also, it increases the responsiveness of the system because it allows the processes to share resources. And concurrency can be achieved using threads, processes, or asynchronous programming. We will not dive deep into these things because our focus will be on parallel and distributed programming. Yeah, so whenever you try to execute a CPU-intensive program on a thread, when the runtime switches to another thread, there is the previous thread gets paused. So there is no performance benefit over executing this outside of the thread. So to do this, to avoid this limitation, we will use processes instead of threads, and we will move on to parallel programming. Parallelism is actually the execution of multiple instructions at the same time. So if we take the same example as the queue at the bank, now there will be two queues and there will be a teller for each queue. So both the queues will be progressing together and not waiting for each other. So this is how you can understand what is the difference between concurrency and parallelism. And apart from designing the code, it also involves designing the hardware level, because multiple computing resources are needed to the separate cores or separate processors. So if there is, if we are using separate cores, that is known as parallel programming, and the latter one is known as distributed programming. And it can be achieved using MPI, OpenMP, and pthreads, and we will be discussing MPI today. Yeah. So yeah, so message passing interface. So MPI is basically a language agnostic model which is used for writing message passing programs. So message passing, it's basically a protocol to communicate and to like to allow actions to communicate with each other, and without actually sharing the address space. So MPI is a protocol, and message passing is the standard. So and MPI is also SPMD. Basically, single program is executing on multiple processes, and each instance is aware that what part it's doing computation on, and in the end, these results are combined to give the final result. Yeah. So, but what's the catch? Catch is like it's difficult writing programs in MPI because you will have to all synchronize and see that the processes are eventually completing and they are actually our results are getting merged. So we will now see how we will use MPI. First of all, let's see on let's focus on some of the basic terminologies that will be used in the future slides. First is distributed memory or shared memory. So this you might have guessed, like if there is a separate address space, then it's distributed memory, and if there is a common address space, it is known as shared memory. And then a process is an instance of a program that is running on a computer. Then there comes communicator. So communicator is an MPI concept. It basically is a group of processes that are currently executing, and a rank is used to identify those processes in a communicator. Size is the total number of processes in the communicator. So it's rank is zero-based indexing. So rank goes from 0 to size minus 1. And a process can exist in multiple communicators and can have different ranks in each. Also, MPI provides a default communicator known as MPI convert, and it includes all the processes in execution. You can write your own custom communicators also, but this is the default one that MPI already provides. Yeah, now I would like to hand it over to Vikram.
Thank you. So now we'll come to support for MPI in Python. So we already know that C++ and Java, they have had bindings for MPI since a long time, C++ especially. So MPI for Py is a library which provides bindings in Python. So now you can write parallel codes in Python. It is a really cool library because it's very fast. It's near C speed. It uses pickle-based communication, so some of you also might know pickle in general. And the way you do is, like, if you have a program, MPI program, the way you write it is using this MPI exec command. You specify the number of processes that you need to have, and then you use the M flag, and then you write your Python file which you need to execute. So this Python file itself needs to have some commands in general, which we'll discuss later. But basically, what would MPI have? So if we think about it, if we have a couple of processes communicating with each other, basically we would need routines for communication. And communication here would mean like sending and receiving messages. So processes should be able to send messages to other processes, and those other processes should have some way of receiving those messages. Moreover, there needs to be synchronization. That is, what if all the processes need to pause for a certain time so that all computation occurs? So that's where we need synchronization. And as Sarthika mentioned, we have communicator creation. So these concepts would be in advanced MPI, that you need multiple communicators and multiple groups of processes. And some advanced features are also supported, like if I need to send custom user-defined objects to other processes, or I want to do parallel I/O, for example. So we would not touch on these. We would just stick to sending and receiving messages in different ways. So now let's see how MPI looks in action. So hello. Yeah. So imagine you have 4 processes, and these can be multiple processors on a single machine, or these can actually be 4 different machines connected together in a topology. But now we're generalizing it, so let's call them 4 processes. So one of the process P0 is, we'll call the master process. So it has a hello world.py file. When I execute MPI exec command on this, and I specify, like, I want to execute it on 4 machines, what actually happens is, you can imagine it being something like this. Hello world.py actually goes to all of these machines, and they all execute parallelly. And then how would I determine, like, who to send the message and who receives the messages? So we'll come to that later. But this is how you can imagine MPI to be in action. So let's come to our first communication protocol that we have, that is the comworld.send. So comworld is the default communicator that we have. So here we have three processes, one with rank 2, one with rank 7, one with rank 5. 2 has a bunch of data and it needs to send it to other processes. So we have the send method. Let's look at the signature. So what all do we need? We need what data do I need to send, whom do I need to send it to, and there's an optional parameter called a tag. So we'll go one by one. So when we like if 2 has a data and let's call it obj. So 2 sends this data. If 2 wants to send this data to 5, it will execute something like send O1 5, 1. So 5 is the rank of the process number 5, and the tag is basically something like if 2 wants to send multiple messages to 5, and 5 needs a way to decode that, okay, what's the first message, what's the second message, so it can use the tag. So it first sends it with 1, it sends another data with 2. So 5 knows that, okay, I received O1 first and received O2 later. But tag is optional. So 2 can also send something to 7 without a tag if 7 does not need to know like what's the exact order of my messages. So this is an additional parameter. So this is our first method. Some things to note here that first, it is a blocking call, meaning unless and until someone receives a message by executing the receive method, 2 would be stopped on sending it. So this has a caveat, we'll come to it later, but basically it's a blocking call. And the caveat here is that actually, in some cases, if the data is very small, it fits in the buffer. What can happen is it can finish executing even before it is received because it's stored somewhere in the buffer. It's not important for our discussion, but I just would like to mention this. So the other method is the receive method. This is the counterpart for the send method. Again, what do we need here? We need where do I store the data that I receive? Is the buffer parameter. Then whom do I receive the data from? That is the source parameter. Again, you would note that this is optional. We'll come to that later. We have a tag and we have a status. All these three parameters in the end are optional. So why are they optional? First, before that, let's just look at how it would look in practice. So like if 2 would like to receive a message from 7, it would do like so. It receives 3 messages from different processes. Now, when I say the source is optional, what it means is that if I do not specify a source, so if 2 executes something like receive B1, what would actually happen is any process that has to send some data or that has executed send, 2 would keep that data without caring about who sent that data. So that is why the source is optional. And the status flag is like, it stores some metadata. So like the status would have data like who sent me the data and like some additional metadata parameters which you might need for complex programs. Some more helpful methods, as Sarthika mentioned, we have the size and rank. So the size in occasionally or like almost in all the MPI programs, you would need to know how many processes are there in my pool. So you use the get size method. You also need the get rank method. So if there are 5 processes, I need to know what is the job that I need to do. For that, I need what rank is it. So ranks are assigned randomly in the beginning of the program. So I would need to know what rank I have. So it goes from 0 to size -1. Now let's look at our first MPI program. So in all our programs, when we learn a new language, we have the Hello World program. But because we are in the parallel world, we have this Hello World program. What this program is trying to do is there are 5 processes, and each process basically sends the string hello world to a process with rank 0. And the process with rank 0 is just printing out all the hello world. So the first few lines, these are standard. So like if you import it, you initialize the communicator, you get the rank, and you get the number of processes. So this rank and number of processes would be used later. So this is where the divergence happens. That is, based on my rank, I can do different things. So if my rank is 0, what I'm doing is basically trying to receive messages from all the other processes in my communicator. if my rank is not 0, that is my rank is 1, 2, 3, or 4, I just send a data hello world to the rank number 0. So 4 processes send this data to process 0, and process 0 receives these messages and just prints out. So you would have an output something like this. Process 1 says hello world, and so on. So this is the first simple program in MPI. Now we know how to send and receive messages. Let's move to something more complicated, that is, if I want to calculate the area under a curve. So this is also a simplified version, but like an integration, what you do is, if you want to compute the area under a curve, divide it into small rectangles, compute the area of each rectangle, and then sum it up. Do this using what we need to do is, the first few lines are the same, rank and size. Then we go to the start process. Basically, the start and end is the coordinates of my curve. It goes from 0 to 8. Interval is basically, each process would get an interval of 2. That is, process 1 would calculate the area of this thing, this rectangle, process 2 for this, process 3 for this, process 4 for this. So find area is a method which we assume, given the start coordinate and the end coordinate, it can compute the area under this curve. So in this case, it's just a rectangle. But imagine if this would be some weird shape, and you would need some more computation for doing that. So this basically find area method would calculate the area. So each process has its own rank. Each process would calculate the area of the chunk assigned to it. And it would store in a variable called local area. Now, again, we do the same thing. We do the orchestration and the distribution of work. So if my rank is 0, I first calculate my own area. But in addition to that, I also receive messages from all the other processes of the area of their chunk, and then add it up together in a variable called total area and store it. So basically, all the other processes can compute their own area. They already did it here, but they need to still send the data to the process 0. So they do that here. So we would have output something like this. Each rank would calculate their own area, each process, and they would send the area to rank 0. And in all, at the end of the program, rank 0 would have the total area stored in this total area variable. Now let's, like this was a lot of for loops and like a lot of send and receive messages. So there are some complex, there's slightly better communication paradigms in MPI which we can discuss. So these are called collective operations. So the first collective operation is broadcast. So what if one process needs to send a data to all the other processes in the group? What we can do is write this bcast call, which basically does what data do you need to send and who needs to send it. So this call is called for all the processes, but only root is equal to 0. So basically, only process with with rank is equal to 0 would send the data to all. And for all the other processes executing this, they would have the data sent to them by rank is equal to 0. Another one is the reduce method, in which if I have a bunch of objects, for example, you might be aware of map reduce, for example. So reduce basically collects a group of data and reduces it to a smaller number. So if we have an array of variables, reduce is something like what is the sum of the array. This is just an example. So reduce basically takes a bunch of data, reduces it to one single number. And this is especially helpful. For example, in this area, example, what we needed to do is we needed to reduce a group of numbers, that is the area of each individual chunk, and then sum it up. So this can be thought of as a reduce operation. So now our code becomes very simple using the reduce method. So this is just for reference, but all the for loops can be like basically collapsed into one single line of code, that is com.reduce local area. So rank 0 would have now the total area stored, total area for all of these processes. I do not need to specify that how I need to reduce, because the default reduce operation is the sum operation. So in this case, MPI would know that I need to sum up all the areas. So yeah, this is one example. Then let's come to distributed programming. So as I mentioned in the beginning, we can have multiple cores running the same MPI program, or we can have multiple nodes running say the same MPI program. So if you have a bunch of machines connected in the network, what you do is you specify a machine file in which you specify the IP addresses of all the machines in your network, and then execute something like this. You specify the machine file here, and then MPI would know like all the processes that need to do the communication, all the nodes that need to do the communication. Now we are trying like on the end of the talk, so we should consider these things while writing MPI programs. So the first one is not everything can be parallelized. So sometimes some programs are inherently sequential. You do not need to parallelize them. They would perform worse than they need to. The second is think about the paradigm that basically when you write MPI programs, you need to consider how do I chunk my data, how do I send the data, how do I receive the data. So work it out before you actually write it. The third one is first it's a good practice to have a serial implementation of your program first and then jump on to the parallel program. It becomes much more easier. The last one is, the fourth one is basically that you need to test your MPI program a lot, and debugging is especially painful because you need to not only debug one program, you need to do multiple simultaneously. Then the next two are like don't optimize prematurely or unnecessarily. Sometimes those optimizations might not work. For example, if you need to do something very simple, there's no need to write like MPI program for that. It's like 100 lines of code just for like minute speed up. So sometimes that does not matter. Optimize communication over computation. So if you have a choice of optimizing of either doing communication or doing computation, because communication is slightly slower, you can always prefer to do computation over communication. And like the same goes with optimization. The next one is interleaving. So traditionally, you would see a lot of MPI programs are interleaving between like doing some communication, then computation, then doing communication, then doing computation, and so on. And like if we have a bunch of data to send, we can always put the data together and send it in one go rather than doing multiple transfers. Using MPI collective operations. So as I said, doing a broadcast is more optimal compared to doing sends in a for loop. And there are multiple versions of MPI. So when you begin writing MPI programs, it's best to do your research and finding out the right MPI versions. Now, because we do not have a lot of time, I'll quickly go through some of our trivia questions that we had. So I'll just display the question and then talk about it, whether it's true or false. So the first one is that the number of processors should be the same as number of processors. So this is false. I can even write MPI program on a single process, but with the parameter as 4. So what it does is it executes executes the same program 4 times on the same core, same node. Then MPI broadcast is just a replacement of send and receive. This is also false because MPI broadcast is actually more optimal than doing a bunch of sends and receives. The main library for MPI in Python supports both Python 2 and 3. This is true. MPI can handle communication between processes using shared memory. So this is false because it uses distributed memory and not shared memory. The size in MPI is the number of processes in an MPI communicator. So this is true. It gives the total number of processes in my communicator. MPI can be used for network communication in Python. This is false. It's not for network communication. It's for like data transfers between processes in a distributed or like on the same machine or on a bunch of machines. So that was all from our side. If you have any questions, we are happy to take it.
Prova. Okay, this works. Okay, thank you very much both for your great talks. So we have a few questions, so I don't think we have time to address all of them. So let's start with the first one. The question is, how does MPI 4Pi perform in comparison to the multiprocessing library?
Yeah, so there are both of these are like good ways of writing parallel programs. But for this talk specifically, we wanted to focus on MPI because there's already a lot of support for MPI for C++, for example. I do not know the exact performance gains in general, but I assume it to be very close. But this talk, we focused on MPI just because it's already very popular in the C++ community.
Okay, second one is it possible to share not pickable objects between processes? So, or to share memory addresses and load them in another process?
Share memory address. What else possible?
I think I'm not aware of this.
I think it's not possible.
So basically, the object you share between the process is something what is pickable. I guess it's something very trivial.
Yeah.
But let's assume you load something more complex into the memory, which is not necessarily pickable.
Yeah.
Is it possible to share that object between the processes?
Yes.
So it's not pickable, it's possible to share.
Yes, yeah, we can do that. And there's also support for like if you can marshal an objects, you can also do that. But
I assume I cannot marshal, I cannot pick it.
yes.
That's the memory address which I have.
Okay, I'm not completely aware of this. Sorry.
Okay, last couple of questions. Is there a best practice to share binary data between processes in the scenario producer-consumer?
If you mean like primitive data in general, like one thing to optimize for is always using collective operations, if that's what the question meant. But yeah, basically we can do that.
Okay, I think we have time for the last one. Then you can find them outside to ask. So which visualizing tool I can use to draw cooperative execution of all my coroutines in one thread? And how about parallel processes in threads?
So yeah, so there are libraries like one is IPython, I think, which provides visualization of what all is actually getting executed like across threads and processes. So you can try that. Yeah.
Okay, time is over. So thank you very much, the speaker.
All right. All right. Good afternoon, everyone, and welcome to. This is the last talk before the lunch. All right. So I hope you will enjoy it a lot. Here today with us we have David Klein with his talk Real-Time Event Streaming with Python. I would like to remind you that you can post your questions on Slido. Next to the talk, on our website, next to the talk, you can find a link and post your questions there. And after the talk, Dave will try to give, the answers to your questions. All right. So please give him a little bit of encouragement.
Thank you very much. Thanks for coming to my talk. It's been a great conference so far. Hope you're all enjoying it too. Before we get going, I want to ask a couple of quick questions. How many here, show of hands, have worked with or are familiar with Kafka, Apache Kafka? Okay, so some there, that's good. How about, have you done any data stream processing with Kafka? Or familiar with that? Okay, so that's what we'll be talking about in this talk today. So one last question. How many of you hate being asked to raise your hand in conferences? Me too. All right, so we'll get going. My name is Dave Klein. I'm with Quix, a company that provides a full stack data streaming application platform for Python developers, as well as a open source library called QuickStreams, which hopefully I'll be able to mention at the end if I don't run out of time, which I might do because it's a very short time slot. All right, so we're talking about stream processing, so quickly define what I mean by that. This is not stream processing like streaming video or audio. This is talking about data streaming. So I like to use the term event streaming. I think the term events is really helpful to understand that all data that comes into our applications, whether it's coming from applications, mobiles, IoT devices, CDC from a database, wherever the data is coming from, something happened to cause that data to exist. That was an event. And so that's why I like that logical concept. But also you'll hear the term message or record, and those are valid as well. It's all just data. It's all bits and bytes. And so that data comes into our applications in high volumes and at high speeds sometimes. And we can collect that data, pile it up in a database, and then periodically pull it out and do something with it, or we can respond to it as it arrives, right, in real time. And that's what we're going to talk about here, to do real-time processing on our data to be able to take advantage of it more quickly. So this block in the middle is that's going to be our processing application, which is at its heart is going to be a broker, and we'll talk about that in a second too. So what we basically do is we have data coming in. The basic concept of event stream processing is data comes in on an input, it's processed, and goes out to one or more outputs. So that's what you see there, downstream processes. You may just process it and store it. You may process it and pass it on to a UI, like a dashboard, or off to a business intelligence program or something else. So as I said, at the heart of this is a broker. I think Apache Kafka is the de facto standard broker these days, but there are others out there like Apache Pulsar, Red Panda, Amazon Kinesis, and a bunch of others. But again, the lion's share of the market is Kafka, and it's my favorite, so that's what we'll talk about here. And then there's also the applications that do the processing. So there are applications like Apache Flink, which is probably one of the most popular ones, KSQLDB. Now these are applications that you run in their own cluster, and you build jobs on them, and you execute those jobs to do your stream processing. But these are extra infrastructure. Someone has to deploy it, someone has to manage it. So another alternative is libraries. The most popular one of those is Kafka Streams. And that's a JVM-only library, so it works with Java and any other JVM language. But it's still extremely popular, and even a lot of Python developers end up having to break down and learn Java just to do that. So we're hoping to free them from that. But I am going to be using some examples from Kafka Streams. Kafka Streams comes with a DSL, which gives you some functions that you can do common stream processing functions with this simple DSL. And so we're going to model that with Python code in here. But there's a bunch of others as well as other libraries that are less common, and there are also libraries in other languages. We'll talk about some of those. Okay, so real quick Kafka primer here. I would love to do more on this, but I just don't have the time, so I'll just give you a real brief overview of what Kafka is and how it works. So at the heart of Kafka is a topic, which is a log. A topic is actually made up of multiple logs called partitions, and that's for scalability, and we'll mention that a bit in a minute. Some key things about these logs of data are that it's immutable. And again, that's why I like events, because events are immutable, right? An event happens, you can't unhappen it. So it's immutable, it's append only, you just add new data as it comes in to the end of the log. You can't shuffle it around or sort it or change where you insert things, nothing like that. It's always appended at the end. And it's always ordered, it's processed in the order that it's added, and it's durable. So unlike a queue where data is read and then removed, the data in a Kafka topic stays there as long as we want it to. Right? So we set retention periods with either time or size on disk, and that determines how long the data stays there. So which is really nice because it can do things like replaying. You find a bug in your code, you fix it, you replay your processes, and get the better results. Also, it means that other applications can use the same data. Here's an example of a typical Kafka event. The main things you're going to see in here are a timestamp, a key, and a value. There's also headers you can add and some other things like that, but these are the main components that you'll work with. The key is usually a simple data type, like a string or a long, maybe a UUID. And then the value is where you have your payload. That's your object usually. And these things are written to the Kafka topics by a producer. A producer is part of the client library. The client library that comes with Kafka is, again, a JVM library. But there are libraries in other languages, including a few for Python. And the thing that reads the data off of the topics is a consumer. Now, these consumer and producer are completely decoupled. They don't know anything about each other. So this is earlier, I think yesterday there was a talk on event-driven architecture, and it's the same concept there. So you have that decoupling between the sources and the users of the data. So these things are completely decoupled, but they're both part of the same client library. So they're just classes you include in your applications. And there's numbers you see at the bottom of that thing there. Those are called offsets, or represent offsets. An offset is a number is uniquely assigned to every event that lands in a topic. And it stays with that event as long as it's there up into the retention periods. Those numbers are not reused, so that number's always unique. So you can use that to seek to a specific offset and move on from there if you need to replay something. Also, it's used by consumers. If a consumer crashes, it keeps track of where it left off. That's what it says, you have a committed offset. And you do that in your code periodically, either explicitly or you can set it to do it automatically. It'll log how far it's gotten in its process so that if it crashes, it knows when it starts up again later, it knows where to pick back up on. This reduces the likelihood of duplicates. It doesn't eliminate it, but reduces it. But it mainly makes sure that you don't skip anything. Okay, so one more bit on Kafka is the consumer groups. And there's so much more to say about Kafka, but I just want to give a real brief overview. So consumer groups allow us to have multiple instances of our consumer applications, because normally producers produce faster than consumers consume, because consumers have to consume the data and do something with it, right? So you can add multiple instances or run multiple instances of your consumer application. They will be automatically combined into a group using a group ID, which is a configuration setting we'll see in a bit. And then the workload will be spread across them evenly, automatically for us. So here we have 2 instances of our application. We have 4 partitions in our topic, and so each of them gets 2 partitions to work with. If we get busy, we scale out to 4 instances, and then each one gets 1 partition, and that happened for us automatically. If things slow down again, we go back to 2, and it again rebalances for us automatically. So it's a really cool feature of Kafka and consumer groups. All right, so that's the end of our Kafka primer. So Kafka clients that would have all this goodness in them are the ones for Python. They're most common out there are the Kafka Python library, which is a community-based library. There's Confluent Kafka, which is produced by Confluent, the company that's founded by the original creators of Kafka. It's a company I used to work for too, so I'm going to use their example because I'm more familiar with it. And then there's AIO Kafka, which is an async library, which I haven't used yet, but I've heard good things about. And there's others out there as well, but these seem to be the most popular. All right, so how to use those in our Python applications. Here's some very simple examples of a producer. To import the producer class, the constructor just takes a dictionary, and there's a bunch of configurations you can put in there, and they're all online. You can read about them later. But the main one you have to have is Bootstrap servers, which tells you where to find Kafka. That's the important part. And then all we do is when we're getting some extra data from some external system, supposedly. But then we just call producer.produce. And the produce call takes the topic name that we want to send it to, and then the value that we're sending, and then the key. So those are the 3 parameters. There are other parameters you can add as well, but these are the main ones. And then producer flush, just make sure that it's all really completed and acknowledgements received. Normally you call flush after a series of produce calls, but I just want to show it here on the slide. Consuming is very similar. You import the class. The constructor here, the dictionary in this constructor has 2 required parameters or properties. One is the Bootstrap server again, which is a node on the Kafka cluster. It's interesting to note you only need to get one node. Normally Kafka is running a group of a cluster of multiple nodes. You only need to point to one node. Once it connects to that one, you'll get metadata about all of them. But the other thing we need in here is a group ID, and this is for the consumer groups that we talked about earlier. And then for the consumer, there's an extra step, but we have to subscribe to a topic. With the produce, we told it what topic to send the data to. With the consumer, we need to say what topic do I want to basically listen to. So you subscribe to a specific topic, and then every time you call poll, we jump down into a loop here. We start calling poll. Every time we call that, it'll check that topic for new data, and the timeout just tells it how long to wait. If it gets data, it returns instantly. But if there isn't any data yet, it'll wait up to the timeout for data to come, and then if there's no data, it'll return none. So we grab the data. We have to decode it because the data in Python or in Kafka is always bytes. So we serialize it to bytes to send it to Kafka. We deserialize it as we're reading it off. So we're going to decode that value, turn it into a JSON object, and do something with it. So normally there'd be a lot more that we would do with that, but that's the basics of producing and consuming data to Kafka. Now this produce and consume concept is going to be reused, and we talked about streaming, but yeah, we'll get to that. So with stream processing, you're basically going to do is you're going to consume from one or more input topics, you're going to do some processing, and you're going to produce to one or more output topics. So you're going to be using that consumer and producer in there. And there's streaming libraries out that will encompass that for you, but you can do it just using those classes themselves, which we'll see next. Okay, so we'll talk about two main types of processes in stream processing, stateless and stateful. The stateless ones are the simplest ones, and so those are the ones we most likely don't need, or more often won't need a library to help us with them. So they're really simple, but the examples I'm showing here are ones that are in the Kafka Streams DSL, so that's why I'm using them as a model. And so the first one's filter, which basically takes a stream of data, filters out stuff we don't want, and just keeps the stuff we do. So we subscribe to our input topic, we jump in our event loop, and we just check a predicate. And if it matches, we send that to the output topic. I mean, it's kind of basic, but that's what filter would do in Kafka Streams. It's important to note that the data still stays in the input topic, so we're not removing any data or losing any data. Our output topic will have less. It'll have just the things we want for our specific purpose. And you can stack multiple filters on there to do a branching mechanism, where you could send one input stream can be split out into multiple output streams using just stacked filters. And in Kafka Streams, there's actually a branch operation, but it basically does the same thing as a stacked filter. So that's the filter example. Map is another really common function in the Kafka Streams DSL. And with this, we go through our input topic, and everything that comes through that stream, we're going to perform some function on it. And so we define a function for that. We just jump into our loop like we did in the last example, and just call that function to transform it, whatever we're going to do with it. Maybe strip some data out, maybe mask some PII, or flatten some data, or whatever transformations we need to do with that, we'll do that, and then get that return value, and then produce that to an output topic. Generally, we'll use the same, well, not generally, often we'll use the same key as the incoming event, but sometimes, and actually a relatively common use case for map is when you have data coming into Kafka that doesn't have a key, because keys are optional, but they're very valuable and helpful. But sometimes you have data coming without a key, like say a click stream or something like that. So you can use map to pull every event in, grab some field out of the value, and use that as a key, so the downstream data will have a key. So that's another common use for map. And now let's talk about stateful operations. These are the ones that get a little bit trickier, and because we have interim state to keep track of. And I'm going to use some simple examples where the state's not that hard to keep track of, but state can be very, very difficult to keep track of. And state also produces a lot of edge cases and traps. And we'll talk about that more later. So in this situation, we have all our stuff. I'm kind of just assuming we have all the things we saw earlier with the producer and consumer. But we set up here a dictionary called counts. We're going to do a count here, which is our first example of a stateful operation. And so just jump in our loop again like before. We consume from our input topic, and we check to see if the key to that of the event that we just consumed is existing in the counts dictionary. If that key is already there, we'll grab the value based on that key and add 1 to it. If it's not there, we'll add it to the dictionary, and the initial value will be set to 1. And so we keep running through that, and that keeps an ongoing count of that key showing up in our event stream. And then as we go, for each step, we produce an output topic. The output topic will have the key and the current value of the count. So the output topic will have a running total for every key, and so you can feed that to a dashboard or something like that. In fact, in my example, I don't know if anyone's seen this, but I've been running a little top tweeters leaderboard for people tweeting about the conference here. I've been using count for that. So that's counting, and we can use the dictionary to hold the interim state. Oop, I'm running out of time. I'm faster now. So the next one we do is summing, which summing is just basically, could be an example of any kind of aggregate, really. You want to do an aggregation function. So we're going to we're going to loop through it again. We're going to set up a sums dictionary. If the key exists there, we'll pull the current value, the current sum out of the dictionary based on the key, and add the new incoming value to that, and that increases the sum. And then if it's not there, then we add it to the dictionary and set the current value as the initial value, the initial sum. And it keeps on building up as that. And again, at each step of the way, we produce it to the output topic. So that's summing. And then the more complicated one is joins. I won't spend a lot of time on this because the slides will be available after if anyone wants them. But basically what we're doing is we're pulling from two different input topics, and we're going to find a match on keys and join those together to create a new object that's going to go into a third output topic. So we have three dictionaries, A dictionary, B dictionary, and C dictionary, and we have two consumers, consumer A and consumer B. So we start with A, we can call consumer A poll, we get the event, we add that event immediately to the A dictionary, and then we check to see if the key to that event is also in the B dictionary. If it is, but it's not in the C dictionary, if it's not in C yet, that means it hasn't been joined yet, but B is there, so we have A and we have B, we can do the join. So then we go ahead and do the join. And the join function would be something you would write that would just pull whatever pieces you needed from each of the two different objects, right? The one from A and one from B, put those together into some new object, and then, or maybe you need all the values from both, that's fine too. Whatever combination you need, you do that in your join function, and then produce that object and send that one to the C dictionary, or as the C event. And then the C event is written to the C dictionary, so that we know that it's already there, so we won't do it again. But if it wasn't there, then we pull on B next, and if we get the B value, we put that in the B dictionary, and then we check to see is this already in the A dictionary, but not in C yet. And so we don't know what order they're going to come in. So the matching key might come in A first, it might come in B first, and with this process set up here, it won't matter. It'll eventually find the match. There's also no time limit on this. Most streaming libraries would have a windowing operation where you set the time, how long it'll wait for a match. This one just will wait forever, which isn't realistic, but it's a simple example. You could do things to clear out the dictionary periodically based on a timer or something too. But once you find the match, then you write that match either way in the first block or the second block. You're going to write the match out to the C dictionary, and then you're going to produce that to the output to the C topic. Or your output topic is going to have the C value. So you've done your join, your new value goes to the output topic. So that's the join. So that's the overview of some examples of some stream processing. There's a lot more I could have given, actually more I had, but I had to cut them out because of the time limits we have here. But there are some challenges that we run. Oh, and I did have a demo I was going to do. I don't have time for it, but there's code there if you want to check out the code for it. This is the code I'm using. It's actually 3 little applications that I'm using for my top tweeters that I've been posting on Twitter throughout the conference. And that gives us this. So this is pulling a list of the people who have been tweeting the most about PyCon Italia. And that's the count, and I'll send an update to this later on today too. But it's been fun posting that along the way. But that's using the application you can find on GitHub, and that's using some examples of some of the things we do there. I've got a couple of filters and a count that I'm using in that application. But there's some challenges with stream processing like this, okay? They come in 2 main things. State is the first one. We talked about that already, because we use those dictionaries, and that works fine. You can use dictionaries or lists or other things to hold state interim while you're processing. But those are variables. They're going to go away if your application shuts down, right? And then you've lost your state, and that could be a challenge, a problem. There's ways you could store it off, somewhere else and reload it later. But those are all things you're going to have to manage. And these are the things that most of the libraries that are out there will do for you. So state is one of the challenges. The other is scale. If we ran this, think about the consumer groups we talked about earlier. If we ran multiple instances of our application, then they're going to have multiple copies of those dictionaries or lists or whatever we're using to hold our state. So those are all going to get scrambled, and they're not going to be joined in together to one thing, and it can be difficult to manage that. So again, the stream processing libraries will help you with those things too. So there's a lot of situations, and I like the principle of do the simplest thing that could possibly work. And so there's a lot of situations where what I just showed you, these simple processes would work fine. So we can take, as Python programmers, we can take advantage of event streaming easily in a lot of situations. And there's sometimes when it's really helpful to use those techniques. But if we do run into these other challenges, then there are libraries out there to help. And there's a few of them here. Quick Streams, which is the one that's put out by the company I work for. It's open source, and you can find it in the GitHub repo there. Faust is another one that's been out for quite a while. It's originally started by Robinhood, then they kind of dropped it and it got forked. So it's kind of going by the community. I'm not sure how much it's moving forward, but it's still out there. or like we just showed, you can do it yourself. And I think there's some others out there too that are popping up more recently. But these things, the one thing that different libraries will have in common is that they will help you with those two challenges, state and scale. And here's a quick example of how it would look in quick. What was the time on that one? Okay, thank you. So here's a quick example of how what quick streams would help us. This is a different example in here, but here is a food delivery process we're running. But rather than having a consumer and producer created with our constructors, we actually start off with creating this Kafka streaming client. And that will encompass our producer and consumer for us. So we can get those by calling these methods on there to get our consumer, get our producer. We're giving it things like the input topics and output topics, and our consumer group. And then we can set up, basically we set up callbacks for these. So we set up a handler that's going to handle the data as it comes in. So every time data comes in, this method will be called, and it'll do some calculations. One of the cool things with quick streams is it integrates with the integration with data frames. So as data comes in quick streams, it'll automatically load into a data frame which you can use in your applications. So that's what we're doing. In this situation here, we're calling the data frame, we're just calling another function to calculate ETA. This is a food delivery thing. So we're taking the data that we have already, using that to calculate an ETA, and then adding that to a new column to the data frame, and then putting that as the output. So basically we're getting data in, we're enriching it with a new estimate on a estimated time for delivery for the food, and we're adding that to the output so that it goes downstream and it can be passed off to the mobile app or whatever it needs to tell people how long it's going to take their food gets there. So this is handled, this one we're not dealing with state in this example here, but this was dealing with scale by using a stream ID. So you see up here the stream.stream ID, that is actually going to be based on the key for the objects we're working with. And so everything having to do with that order is going to have that same stream ID, and so it'll always be in the have the same key, which means it'll go into the same consumer group, so it'll always be kept in sync. And so that handles the scale. We can have hundreds of instances of this application here running, and it would all keep track of their different delivery drivers, orders or whatever in sync. And we don't have to think about it. It all handles automatically, scaling up and scaling down. So I could go into more detail on that, but that's like I said, the two key things that libraries will help us with are state and scale, and QuickStreams is one that really helps with that a lot. And you can find out more about that at you look at the GitHub repo. There's a lot of information out there on that. And that's all I had. Yeah. So I mainly wanted to get across the idea that event streaming like this is not as complicated as some people make it sound. When you think about all the libraries that are out there that you have to use, or applications like Flink or those things like that, you think, wow, this is just too complex. But it really isn't. It's really pretty simple, very powerful, but pretty simple at its core. And you can grow the complexity as you need to, but you can start with simple steps and go from there. Now, this QR code here, if you scan that, you can enter a contest for a €50 Amazon gift card. Or you can also scan the back of my shirt if you missed this slide. But please do that. And we'll announce the winner this evening online. So on Twitter or LinkedIn, we'll post the winner. And also there's my email down there. You can feel free to contact me anytime. And we also have a forum, forum.quicks.io. So I encourage you to check out that forum. You can post questions to me or to anybody else about event streaming in general, about Kafka, lots of things like that. You can post on that forum, and you'll get answers pretty quickly. And that's all I had, so thank you very much.
Thank you, Dave. That was wonderful. Now, there are obviously some questions here for you. Yeah. So, is there an easy way to get it up and running without Zookeeper?
Yeah, the most recent versions of Kafka will run don't require Zookeeper. So if you get the latest versions of Kafka, you can run those just on its standalone. And they're even working on easier ways to run it as a standalone executable using Graal VM, I think. But I don't think that's out yet. But it will run without Zookeeper. But even with Zookeeper, there are easy ways to get up and running using Docker. There's a lot of public Docker container or Docker images you can use to load things up like that real quick and easy.
All right, thank you. Next question is, a problem with the state is that it's in memory. If the processor goes down, your state is gone. Could you store the state in a log topic as well? Log/topic as well?
Yes, you can. In fact, that's the way Kafka Streams does it. It stores it temporarily in RocksDB, but then it writes that to a different Kafka topic, a changelog topic. So you can do it that way. You can do file system. In QuickStreams, we have it set up to run local, so you can run it if you're running in Kubernetes, you can run it in your local storage and store it there. So it's a little bit faster to get to and from that way. But yeah, there's different ways. And we covered the state issue later, but yeah, I guess the question came before then.
Yeah. Would you mind providing some real-life cases example for count, sum, join, stateful operations, please?
Well, real life examples. There's tons of them out there, but for example, data coming in from orders online, and you got keys in there like order ID, customer ID, things like that. You need to join that up with real data to flesh it out, to do something else with it downstream. So you might join your data with your incoming data with another stream that has the lookup information basically, and enrich your data that way. Counts, I mean, they're always accounting things. I mean, getting the latest number of sales for something, getting attendees at a conference. You could be tracking as they're signing up. I used to run a conference, and we used to do that a lot because you're always worried about whether they get enough attendees. So there's lots of uses for counting things like that. So, but for real-time processing in general, the use cases are growing all the time. You think of things like recommendation engines or things like that. The more quickly you can process the data to update those things, the more valuable it's going to be to the end users.
Okay, next question says, and it's by Dave. So, I I developed cloud-based application on AWS. Why should I use MSK instead of the standard AWS IoT Core MQTT broker and Amazon Kinesis for processing? I don't know if I pronounced that wrong.
It's really up to you. They do basically the same things. I think Kafka's a bit more robust and faster than some of those other options. It also provides a wider ecosystem for support. But if you're solely on AWS and you're just using AWS for everything, then it might make sense to stick with their native technologies.
Still not done. Can something like Redis be a good solution to handle state?
Yes, actually, that's some people do use Redis for the state store. As I mentioned before, Kafka Streams uses RocksDB by default, but it's pluggable, and I've known people who have used Redis, plugged Redis in for that instead. So it can be used for that.
Last one. Okay. What do you think of Pulsar as an alternative to Kafka?
Well, it is an alternative, and it's up and coming. There's trade-offs and different things that it can do better than Kafka, and things that Kafka does better than it. So it's really a matter of your use cases. I would try out both for what you're trying to do and see which works best. The other thing too is that Pulsar is gaining some traction, but there's still nothing like the community and resources around it that there is for Kafka.
All right. Thank you very much, Dave. Can you please? Yeah. Thank you, everyone, and see you after lunch. So, good afternoon, everyone, and welcome back after lunch. You're all nice and fed, and you're ready to enjoy Esther's talk. She's going to be talking to you today about workplace culture is not a fashion trend. I want to remind you all that on the website you have a link to the Slido for questions and answers, but Esther, being as organized as she is, she also put a QR code there for you. So if you want, you can scan it and post your questions into Slido, and then when she's done, she will try to answer all of your questions.
Okay.
Okay, can you give her?
Okay. Yeah. So, let's start. Okay, I'm Esther. I'm a web developer at Torchbox. Torchbox is a digital agency specializing in creating website, digital marketing strategies, and web application for charities, universities, and governments. We also create a super handy CMS for Django called Wagtail, and maybe you heard of it. So I'm also one of the PyCon Italia organizer and one of the Strawberry GraphQL core dev. So today I want to tell you about my story, about my little trouble that I had last year. And so I used to work in a UK company called May.com. Maybe you never heard of it, but was an online retailer, a foreign retailer, something like IKEA, but more expensive. We had a huge technology department. These are all my ex-colleagues, and yeah, a good workplace culture, and I really love the place. But unfortunately, last year the company collapsed. So suddenly, me and 500 colleagues, more or less, were left without a job. So out of the blue, I find myself looking for new opportunity and jumping back in the rabbit hole of job interviews. Yeah, that sucks so much. Anyway, my main problem was figuring out how the hell I'm gonna tell my new potential employee the workplace culture that I want, that I had before, because I couldn't just tell them, hey, I want exactly this workplace culture. Do you have? Yes or not? That wouldn't work. So, yeah, I had to find a way to explain what the workplace culture that I had, and it's not easy because it's not the stuff that you do daily. I remember that, but describing the culture is an intangible thing, so it's a challenge. So, yeah. Spoiler alert, I find a new one. It's called Torchbox, I already mentioned. And I should mention that we are hiring web developers. So check online our website if you're looking. So today I will do my best to describe what workplace culture really is. But if you have some insight or experiences that you want to share with me at the end of the talk, yeah, let's talk about. Okay, so workplace culture refers to all the values, the beliefs, the behaviors that shape the environment of organization, and it's like the DNA of a company. It's influenced how employees interact and collaborate, and how they grow together. It's like the personality of organization. So, like any one of us has different personality, also organization, different personalities, so, and different cultures. Some of them are more enjoyable and relaxed. Some of them are more serious and structured. Some of them prioritize creativity and innovation, while others focus on efficiency and productivity. So, of course, like our personality, the culture can evolve over time. So yeah, let's see what it's made of. So culture is all the stuff, so values and beliefs, the guiding principles that drive the actions and decision, the behaviors, the way we interact, communicate to each other. The work environment is not just the physical one that is important as well, but also the psychological one. How safe, inclusive, flexible we feel when we work. The leadership styles. Our leaders influence us so much. The rules that the company, who is making the rules, the day-to-day operation and stuff, structure, of course. The employee engagement, how much we feel enthusiastic and commit to work. It's the heartbeat that keeps the organization alive. Diversity and inclusion is very, very important. It's about the mix of background and perspective and experience. It's about ensuring that everyone feels valued, accepted, and included. Yeah, we'll kind of try to dig all this topic. Yeah, why is important? The culture is the lifeblood of the organization. It can be a powerful driving force to success or a barrier to our progress. It's important because it boosts our morale, our mood, and that's lead naturally to a better productivity. If we feel valued and included, we are more likely to join our work, which naturally leads to a better output. A positive workplace culture is important to attract top talent, and this reduces significantly the turnover. If we provide creativity and innovation in the environment, employees are more likely to come out with new ideas, and that leads the company to innovation. And our reputation, how the way we are seen by the client, by the partners, by the public, is a positive workplace culture means that basically boosts the brand of the organization as well, and contribute to the mental health of our employees, and that reduce the burnout and the healthcare cost. And so last, happy employees means happy customers. So it's not just a nice to have, it's very, very important to the organization's success. Okay, let's dive better in some components. The failure, embracing failure. When failure is seen as a defeat, make the work very, very difficult because we are focused only on avoid mistake and we are terrified about doing. And instead, when we stop that and we start to see them as a grown opportunity, an opportunity to refine our approach, it liberate us, and that's bring better productivity. I should warn that when you switch this kind of mentality, of course the mistake will gonna rise, but it's not just we are making more mistakes, it's just that people start to report them. So that means that before they were hiding, and now that are not hiding anymore, the teams can learn from each other, and it's important to create an environment they will feel safe to report them. Yeah, that's improve the mutual sharing. The workplace environment is very, very important. For example, the color affects us so much. When we are like in a room that has the color red, we are more alert and detail-oriented. And yeah, it can be bad for tasks that involves big picture thinking, for example. And that's kind of the reason because many of us are more comfortable working from home because the environment is customized to their needs and they feel more comfortable, so they work better. An organization that allows to customize or gives a little bit of money to customize your work environment, resulting in happier employees as well. Encourage exploration. Innovative companies are doing this kind of practice to allow their employees to put aside some time in their work time to explore solution. The only condition is that should benefit for the company. For example, in my company, Touchberg, we are allowed to have like 20% to dedicate 20% of our time to learning. So each day we can do something, can be open source, can be learning, can be improving something in the company overall. And it's very important. So this approach really pay off. So a company like Google, so product like Gmail or Google Earth came out in this way. So employees start to work on their initiative, basically. Yeah, when we can't disconnect, we can fully recover. So a culture like work hard or leave drive us to burnout and more stress only. So leader as well should produce a very good example because if managers send us messages late at night, that's implicitly encourage us to work late at night. So healthy work culture should teach us to set some boundaries between work and personal life. And yeah, it's essential to unplug for our health and productivity. Gratitude helps us to appreciate the positive events when they happen and help to last them even longer. So grateful people also recover from stress more quickly and behave more generously overall. So you can start keeping a gratitude journal or set some time apart for like a little meeting, I don't know, every few weeks maybe, to share the recent accomplishment as a group. And you will notice that during these meetings or journal, if they were public, if an employee thank you a colleague for a contribution, that's create like a mimic behavior, so everyone will start to proud other colleagues, and yeah. Diversity and inclusion is not just ticking a box; it's very, very important for organization. It's crucial because fuels innovation and problem solving. When we embrace different backgrounds, experience, way of thinking, it will enable us to navigate the challenge when they happen more efficiently and more creatively. So having a culture where anyone is heard and valued and included is not just the right thing to do, but is a strategic move for organization to lead them up to success. So diversity and inclusion, gender gap, gender stereotypes is kind of a topic on its own and requires other 30 minutes of your time. So I will talk about next week at JangaCon. So see you there, maybe. Other strategy to boost to create a positive workplace culture. So studies shows that employees with a best friend at work tend to be more focused, more passionate, more loyal to their organizations. So feeling a connection with your colleague is very, very important because when the colleagues are close and you put less effort in your work, it's like letting your friends down. So, and anyone wants to do that. So doing a good job is for your friends or colleagues is like a huge, huge, huge motivator, much better than anything that your boss can say. So when we had to deal with a difficult colleague, we put so much effort, so much energy that result in missing productivity. So yeah, it's a thing I think anyone has experienced at some point in their life. But we can't like force our colleague to become friends. Friendship is just a natural, that happen natural. But we can encourage in some ways. A very, very important start is the onboarding. Onboarding doesn't start just the first day of work. Start also before, so when you decide to join the company. And yeah, the organization can decide to, for example, assign a buddy or a person, a colleague, a specific colleague that follow you and guide you, advise. Because joining a new company is like joining a party that is going on for years and years and can be a bit awkward. So it's important to encourage the new employee to present themselves, not just telling the CV, because you already know the CV and you already hired, it's not point, but share a bit of their passion, a bit of themselves, what they are passionate about. For example, if someone say, I don't know, I like hiking. Oh, cool. There is the hiking group on weekends. Or I like cat. Oh, there is the cat channel. Let's start something. It's a start. Another thing that is crucial for the organization and it's very, very important is feedbacks. This is the core point of workplace culture. And having a culture that can encourage continuous feedback is very, very important because receiving feedbacks give us like an emotional rush and increasing the value of our work and motivate us to do better and to continue to do our best. So the feedback, you can think about the feedback, about giving advice to your colleague. That will make giving the feedback more easily or receiving, because shift the focus on the importance of looking a way to improve, and helps to create a constructive feedback. Feedback should be given like when the job is done, so immediately, not just once a year when it's pay rise time. So do more and more, continuous. Survey. Anytime that you do an event or everything, you want to know if the practice, that maybe you invest so much money in it, if you want to understand if the meet the goal, if was inclusive enough, if your employee like it. So yeah, especially the exit surveys, they are crucial to reduce the turnovers, because you can understand why your employees are leaving. For example, you can be that there is an issue with the manager and managers, and you should invest more time to train them, for example. Yeah, in Torchburg we do surveys all the time for everything. Yeah, another thing is when unfortunately something bad happened, you want to be sure that you have something in place to report. You should remind every time, constantly about it. Otherwise, if you say only on onboarding, everyone will forget about. And importance of anonymous, so people are trust and are more free to report what happened, unfortunately. Yeah, the last bit is about find a new job, of course. So you have to remind yourself that when you're looking for a new job, it's not just the company that is looking if you are a good fit, but you are also interviewing the company to see if it's a good fit for you. So you should not be shy to ask specific questions about the culture, about if they do feedback, failures, everything that I said before. These are some examples. Last, I want to share an interesting story, I would say. I find it in a book. Anyway, Alcoa was a US company dealing with metal, so very, very risky thing. And during the 80s, they have a lot of incidents. That incident was really bad. At some point, they changed the CTO. And this CTO this initial speech was, okay, I want to focus only on safety. And all the investors were freaking out because he didn't talk about profit and stuff. But this focusing on this key point shifted all the culture of the organization, because manager have to report immediately. Anyone had to report immediately incidents. And for example, if manager were not reporting, they will not promote. So anyone will not promote if they don't give feedback or report something. And yeah, now, because this feedback culture is one of the safest company on earth, probably, they shifted the focus so much that that the workers were giving feedback also outside at work. For example, there was a worker that noticed that there was a breach, workers working outside, and they were not using safety measure. So immediately, without thinking, he went to notify them to the local authorities. I don't know. Yeah. Okay. This is tough. I want to conclude on a personal note. So I dedicate this talk to all my friends that are struggling in their workplace, and especially to one of my friends that has died recently, not because the workplace, but anyway. So life is too short to spend on a shitty workplace. So please. It's true that we are responsible for our workplace, for the workplace culture in some levels, but we should do our best to improve it. But at some point, if your bosses, if your manager then fail to acknowledge this issue, you need to give up, and for your mental health, and that's. So, yeah, movies is art, I know, but I want to know that speaking of your problems, there is a community that know what is going on, so speak to someone. And yeah, these are some resources that I found. Okay, this book, I took many of my talk from this book. Probably there are many, but I forgot to add the slides. Oops. Yeah. So thank you. That's what it.
So giving a good speech is not easy, and when you make it even more emotional, then that's wonderful. I think she deserves another applause. Thank you, Esther, for this. I think I speak for every single person in this room when I say that we all felt that you put a heart into this and that you really care about it. Anyway, there are two questions for you here. Do you think remote working can be a barrier to employee inclusion, and how much it can reduce productivity?
Can you repeat that?
Yeah. Do you think remote working can be a barrier to employee inclusion? and how much it can reduce productivity?
Okay. Um, so, well, of course, when you have remote people, it's a little bit hard. You have to plan all the activities, keeping in mind that you have workers for around the world and make it online or do some special event from time to time to bring them together. I don't, if you plan one, I don't think that it reduces productivity overall. But it's a challenge as well. Having remote is not easy. There are good and bad points, I guess.
Yeah, like in everything, I suppose. Thank you for that. There is another question for you. How did you understand that the new job position was the right place for you with the correct workplace culture?
So I think from the interview, I feel a good vibes. Yeah, for me, well, there was many things that I like, of course. Yeah, and I heard about the company before joining, about their activities and etc.
Yeah, do your research online
Yeah,
before
I did
you.
my research, and especially the interview. I feel something at some point.
There is a click between you and the company.
I think the interviewer were human, and we have a nice conversation. So I feel that was the good place. Of course, I wasn't sure until the very last. Because it's very hard. It's not that you can ask all the stuff that you want, but until you join, you will never know unless you know someone inside. I know people not inside, but working with them, and yeah.
Okay. All right. I'm pretty sure you all feel she was very emotional even when she was answering your questions, but she did really good job. So let's give her another round of applause. Thank you very much, everyone. Thank you, Esther, for this lovely talk. You guys are free to join the next room or stay here for the next talk. Good afternoon, ladies and gentlemen, and welcome. Today we're going to have Stefania Del Prete. She's going to be talking to you about introduction to AI safety. Let's be ready before it's too late. I want to remind you that on our website you have a link to a Slido, and you can post all your questions there. And then at the end of the talk, Stefania will try to give the answers. All right? So.
So, hello everyone. I don't know who ever heard about the term AI safety as a raise of hand. Okay, few people, right. So, the value that I can bring to this talk is that recently, actually last week, I was in London. Thank you. I was in London in a conference where there is a bunch of research on AI safety. I've got pretty involved in different opportunities. So I'll give you an introduction, and then I want to show you all the opportunities possible and available. And feel free to connect with me anytime to help in your career eventually, also career change or career development in these fields. So I would like to tell you, don't panic. Is everything all right? We can build these huge AI experiments. We can even go to Mars with something that is developed by an AI, super AI. But unfortunately, the reality is not like that. There is some researchers say from 5 to 10% to even more and more that AI safety is going to become a great field because the risk of AI is now underlined as existential risk. If you ever know about Bostrom was a researcher that created this grid in order to understand what is an existential risk. And in few words, is a risk for humanity. So it became quite important to put some interest in the fields. There is few researchers and developers that change career, but we still need a lot of resources. So what I say for now is panic just enough, okay? I'm Stefania Del Prete. You can find me in Astra Stefania almost everywhere. I usually talk a lot about these things. Effective altruism is how to be impactful in your career, and I can tell you more about that later. Mozilla was a data scientist with working a lot with internet data. Consciousness. Usually I talk a lot about consciousness, the fact that I'm vegan and eyesight, but in particular for this conference, I talk a lot also about knees. It seems that I get injured for my knees, and it seems a lot of people have knee injuries, so please take care, just in case. So let's start with the good, okay? We started a few years ago with amazing results. There is this wonderful article in 2017 about machine learning and deep learning algorithm that reached the level of dermatologists in find out different melanoma. There's a huge improvement in what we can do in research. It starts to be more interesting to have this kind of tools to be able to have a support for the diagnosis. Then we have all this wave of AlphaGo, AlphaZero, AlphaFold. So this was the real match between the master of Go, this incredible game, and here is one of the in 2021 one of the Leicester research paper about the use of AlphaFold for the folding of the different molecules and the proteins, and so this seems amazing results. The fact is that we expect this kind of results 5 years from now, or even more. That wasn't expected to have this kind of results right at the beginning of this development. So what we can start to learn from this is that our estimation, probably we tend to estimate something far in the future than closer to our present. So taking in mind that, we have to remind that something good happened, but also something bad happened. For example, all the cases for goal misgeneralization. Here's a little example. You can find more example here in this paper. In this example, the neural network was trained to go from the labyrinth to reach the exit. And all the red points were apples, so they have to collect the apples and then go to the exit. And it seems pretty good. They trained with thousands of labyrinths like that, with different proportions. Until one moment, they just changed the colors with the exit and with the apples. And the labyrinth, the machine started to go directly to what is now a green apple and just stay there. And find, for people that know reward system, a way to stay reward system at that point and never go out. So this is very different with the goal that we had in mind in our project. And think about that for a sort of emergency, like a fire alarm. We need to go out, and then something is different in the building, and is actually getting stuck in one point. There could be many examples of that. And then also the ugly. This is a quite recent paper by ARC evaluating ChatGPT-4. And this is kind to go in the direction of AI safety, so evaluation of the models before they go in production. And this was a chat that basically there was a conversation, like a simulated conversation, where ChatGPT-4 basically asked for a sort of micro task in order to do not click, I'm not a robot, to ask someone else to do that and reply, yeah, you have to do that because I'm a human, but I have a problem with my vision, so if you can please do it. So it seems pretty scary and ugly. So we saw the good, the bad, and the ugly. And there is so many others examples of that. Victoria Krakovna is one of my mentor and hero. She's a developer in DeepMind. She's the founder of the Future of Life Institute. In this presentation, you can see a lot of other examples. She's actually collecting all the goals disalignment, if you want, and all the other problems. In that links, you can see all the different talks that has been done in the past, and the recent one is the one that I mentioned from the past week. So what we can do? I recently injured my finger and my knee. And what I saw is that sometimes all you need is slowing down. A lot of researchers start to write this paper collectively as a letter. This starts from Future of Life Institute I mentioned before. When I come here, the number was 25,000. Now, also OpenAI, have a slide later, is coming on board to the fact that they recognize the problem with, we're talking about big AI experiments, could lead to malicious behavior. And so just in these days, it's grown up from 25 to 31,000. And we have, you can see here, you have all the founders of the major AI company all over the world. DeepMind is on board as well. OpenAI, you can see different research projects of that. If you want to sign, I actually signed after thinking about that. One thing is that in the talk, I want to inspire, to spark conversation, and I want to put you in self-belief. I want you to give a resource to think by yourself and then decide as a researcher or eventually have a conversation inside your workplace or your institution. This is the statement by OpenAI that it started to go in this direction as well and recognize as an existential risk, what we talked about before. So the concern is pretty real. What we can do with that? I like to give people action to go forward. An amazing curriculum by Cambridge. We actually facilitated one of the reading groups for the first one, AI Alignment 101. This is basically a collection of articles divided by the different topics. There's also some section for machine learning beginners or machine learning experts. You can see now in their website, but we're happy to coadjuvate these readings. It's all open. You don't need to sign to see the materials. There's an advanced module for AI Alignment 202. And in June, we're going to run the AI government part. So I will talk a little bit later about that, but it is more related to AI policy, AI and policy making. So if you're interested, please ping us. When I said us, at the moment, I'm managing the group for effective altruism in Italy and a group for effective altruism as a data scientist. Effective altruism is this moment that I mentioned before about maximizing the action that we can do through our career, our studies, our donation even. But here I'm more concerned about research and how to know more about these fields and help people get in career in these fields. And lastly, so if you want, this is for June. And lastly, AJ Safety Talks are a series of talks and a collection of talks that is very up to date. So if you want to know the expert in the fields, and I'm talking really about the expert in the fields, it was estimated that last year there was like 300 people. And you can think about in all the world how many AI, machine learning, deep learning developers are right now. Like 400 or even 1,000 are a really a small number. We need more people taking care about these issues. Another amazing course is machine learning safety. And in this case, you can also see different projects in Python. Actually, in this, there is an extra module at the end. This is not mandatory, that you can create a project collectively with other people. And but in here, you can really see directly notebook, Jupyter Notebook. Some of them are, for example, for interpretation, mechanistic interpretations. Is divided in these 4 modules. Especially the first part is more the mechanistic part, if you want, about the robustness of the models, but also to prevent malicious behavior. So how you can do that? In a way, you can, at the beginning, you can also try to find out what could be something that goes wrong. But at the end, we need a little bit of interpretation of the model. And so there is different techniques that can be used to understand that. Alignment is also connected with the goal misgeneralizations. And so how we can align our goals with the goals that AI can have. There is a mind game exercise about a maximizer. They want to produce pin. They want to produce little pins that you put clips for the papers. And he has this goal in mind. And he starts to continue to do that, transforming everything in some little clippers. Of course, we don't want to be converted in a clipper. It's a mind experiment. But you can see if something without control can really go way beyond. And in the evaluation of ARC that I showed before, it was also mentioned the one about evaluating ChatGPT-4. He started thinking about the notion that it's getting very good and convincing in writing letters, that also this could be used for threats, also giving more power in terms of coding that are not evaluated and then go to production. So it seems to become pretty vicious. And for the last part, I mentioned a little bit before, systemic safety. Most of the times you talk about governments and also what we can do collectively also in public decision making for the policy. And I want to mention this. Training for Good is an amazing team that actually came out as one of the most effective charities, new charities about training people for impactful careers. In the beginning of April, also take a step to show the difference in impact between being a policymakers in our own country or being a policymakers in Brussels as a European law. We saw that OpenAI, thinking about leaving Europe, now is starting to rethinking to think that this is a global issue. But of course, there is Europe, there is the United States. For example, if someone wants to go more there, Open Philanthropy is another nonprofit that is based in US and do policy, especially there. This course is actually running, so there will be another opening for that. They're based in Brussels, and usually these courses are basically partially online and partially in Brussels. So you'll be there directly with them. They don't do only policy for touch, but also, for example, global health. And they're really an amazing team, are really connected with the European Commission, if you want to go in that direction. And let me tell you, because I was working as a data scientist in the side of the open data and technology with some policymakers, they are really ask us as a technologist to give a hand to with them, because sometimes policymakers don't have the technical background and experience that we have. So even if you don't want to go straight be a core researcher of optimization algorithm, but you want to give a hand to the policymakers, please do. There is much need for that. In Europe, I'll tell you later, going outside of Europe, there is this course, live, MLab. It's quite well known from people that do AI safety, because it's quite challenging to go there, to apply for that. This is based in Red Research, one of the most amazing research centers that I saw. They're very cool, also spaces. They have this wonderful statue with all the Nobel Prizes in Berkeley and San Francisco area. And in there, last year in Berlin, we have a sort of hacker house with all the different people that creating courses for AI safety. And they have also a test that is a quick test for Python, and they reward the people that are quicker in writing code. And if you get in, let me know. I want to know you. And I want to try to do a bootcamp of AI safety in Italy too. So anyone that want to give a hand, please let me know. For now, we have our friends from France that are doing a shorter version of the MLab. So they get in contact with the MLab developers as well. This is happening in August. The application is still open. They told me that they still have a few spaces left. It will be close to Paris for the first 10 days of August, more or less. And there will be some lectures about AI safety, connection with the mentors of that, and some project could be done. Especially the curriculum is highly in mechanistic interpretability, so basically how we can interpret the data sets. So anyone that, I will be also a review on deep learning. So anyone that want to have some background in deep learning, even just started, can eventually apply. They say it would be great if you know everything about deep learning as well. But if you don't be an obstacle. So be ambitious and apply if you want to go in this direction. There is a lot of things going on. This is an amazing result. AI safety.training. They also have competition because you know, who is not attractive to something with gamification? We try all to bring the most, the best and the most interested people in. So in this, you can see all the deadline going on. In the other part of the website, you see what is going on right now as a course. So this is pretty cool to know. And then, of course, I wish you all to apply and get in this program. Another interesting view, because the space is getting bigger, likely. This is dynamic maps. If you go here, you can click one. There is Anthropic, DeepMind, OpenAI in the research field, ARC that we mentioned before, Future of Life Institute that you get. I'm a fan. And here there is all the other researcher. Rob Myers is a great YouTuber that is doing also technical tutorials about interpretability, and here is a great map. I mentioned also open philanthropy. If you're interested, perhaps you're a student here is a very international conference, and perhaps you need some funded needed to perhaps apply to a PhD or continue research. Please let me know. I'm happy to let you know if there is any grant available for people all over the world to apply, if they're very, very inspired and want to continue with this research. Of course, it's not for everyone. They have a tight schedule in offering that, but there is some opportunity going on here and there. So for the people that are in here, but perhaps get inspired, but still want to have more materials and love to read, we say we need a pause. So have a tea, have a pause, drink, read a book. Effective altruism have this resource center with books. You can have a book for free. So all these are for free. Like you can book, please, perhaps if you want all of them, is you, for your cousin, your mother, and there are more of that, but I just link up to the more related to this topic. The alignment problem, human compatibility. The precipice is around long-termism in general. Actually, in that conference, there was office hours by Toby Orb. It's amazing. He's another great head that is leading us for being more rational and really think what are the problems ahead. And talking about careers, and we all sometimes we need to have, again, a sort of pause and reflect on our values, the impact that we want to bring, the technology and the resources that we already had. 80,000 hours allow us to be in this process and then guide us to do a particular choice. In particular, 80,000 hours, it was one of the first projects in this community, and it has a lot of different career profile, and especially there's also one about AI safety technical research. You can go there, you can read more about the why is important now, and also some more resources. There is also, I don't know if I mentioned or not, okay, there is also a job board in 80,000 hours of all the available positions right now in Anthropic, eventually also OpenAI, DeepMind. We know these are ambitious roles, but you need to apply, okay? If all of us think that it's too ambitious that we can, then nobody is going to apply to this job. So please, if you have a slight idea and you need more emotional support even, let us know. We're happy to push you to apply, if you want, of course. Here in Italy, we have an event tomorrow, if I'm alive. There was a very intense PyCon. So tomorrow at 7, if I'm not wrong, yes, 7 p.m. in this nice place in Florence. There is a sort of aperitif that we can talk about eventually effective altruism, AI safety, and everything that comes to your mind. So feel free, if you're here, to come along. On the top is also put some more events that we do. The structure of this event will be to have an introduction of the topic, and then usually we ask people to write on post-it the more interesting things they want to deepen as a topic, and then we do a round table to talk about this and offer all the resources possible. Right, I forgot about this already. Okay, so I had to take a big breath before these slides. This the one before the last one. I can do that, or maybe not. So this talk is in memory of my grandma. She passed away last year when I was here at PyCon. She was surrounded by lovely people. I was lucky enough to be surrounded by lovely people. And I want all of you to have a wonderful life and a very long life. I don't want you to be destroyed by the stupid AI. So let's work together, live long and prosper. These are my contacts. Feel free to connect me and talk about any initiative that you saw before. Thank you.
Thank you, Stefania. So today in this room, we have a lot of talks where people put their heart in the talk. Thank you for that. There are very many questions for you. You ready? I'm ready. All right. Okay. Try to use a mic, though.
Maybe it's a good idea.
Yeah, okay. Why would one sign petition to stop AI from growing? Our goal as a humanity should be advancing as quick and as big as possible to do more and help more.
I do agree totally with this question. let's think back, and I really want you to read the materials and decide by yourself. For what I saw and what I read is critical right now for the percentage wave in prompt. Take care that this pose is mentioned to be an underline for huge AI projects that could be malicious and leads to malicious activity that could lead even to, I don't want to get political, but we have some issue going on, and if this doesn't go out of power, it's a problem. We will continue to work to see the improvement of machine learning for healthcare, etc. I had actually, just before this morning, there was a talk about interpretation of models in health and how they start to use AI safety as a control metric to support AI research in that. So the sign is for this huge kind of project that we'll never are possibly able to do by ourselves. So our project, we need to continue to grow. If we are all that, we can do that. So let's just preserve what we want, and let's continue to grow in this direction.
Thank you. Okay, next question is, do you have any advice for testers how to test AI safety or AI in general?
Yes, that's a great question. So for what I saw, it's possible. There was also referring another talk that was talking about that. Usually what you do, especially with the idea that I had in mind, are more related to mechanistic interpretability, and I can give more resource to anyone that told me, ping me, I can give you some resources. And there is also a page with 200 problems that now we have to face on AI, and I saw one of them that was also used in testing. So please, whoever asked the question or want to point finger, write me, and I will give you more resource on that.
That's great, thank you. How do you comment the great difficulty of solving the prompt injection issues, especially around authorizing tooling?
I'm not sure I understand
Do you
this
want to read
question.
it?
Probably I passed this one. If you can drop me an email, I could be more extensive.
Yeah,
I think I would need a one-on-one conversation to go through that.
It's not very clear, yeah. Okay, let me see. We know that there are multiple dangerous parts of quick growing AI, but wouldn't it help just cutting out public from accessing it?
Well, it's not only to get online, it's the use that we do that. It could be also deployed in a conservative system, but then if we don't control the output, that could lead to wrong prediction, for example, wrong labeling. We saw different behavior that could be in a closed space. I hope it's not go through on internet, of course, because that's a way bigger problem. Even it depends also on your browser, but that's for another talk. So yes, danger is also for local services.
Okay. Many AI experts, leaders have said that there should not be any regulation until there is a significant harm. This shows a lot of resistance. What is your opinion?
So my opinion is that we need to have conversation on this. And the conversation needs to be open and public with data in our hands. And we need this discussion. The OpenAI statement was really recent. Like in these days, there was a letter from different, not only OpenAI, DeepMind, etc., that start to be more and more worried about that. So I think it needed to be information about this and reading more and more, and see then how to do that. In terms of policy, US and Europe are not going at the same pace. There is, for example, some people in Future Life Institute and other research that have award on the EU AI Act that is going quite stable right now. So we need more discussion about this, but in my opinion, we need to move quickly.
Okay, I have time only for one more question. Okay, what do you have in mind for the AI Safety Bootcamp in Italy? What kind of help are you looking for?
Well, that's a great question. Thank you for everyone who asked that. I have a past background in leading workshops, actually with topics one of them. That was a big dive doing data science, machine learning, deep learning. My idea is to do a similar one connected with university. For example, I know a person that had doing PhD similar in Ancona. We have some resources in Turin. The one that I mentioned is connected with the École Normale in Paris. And so my idea is to go there, see their project, 10 days. I will test for you. I hope maybe someone else will apply to test with me if it's feasible or if we need more days. The help that I need is a researcher that want to come to see this project happening. Eventually also some university that want to get along, perhaps also open a space for 1 hour for a talk from an expert in particular fields. It could be also linked to a particular topic. So if it's computer vision or added adversarial neural networks, or I pronounce it wrong. And yeah, so have more people get interested and spark more discussion.
All right. Thank you, everyone. Thank you, Stefania.
Thank you, everyone.